All right. Thank you, Wes, for the introduction. As Wes mentioned, my name is Sai Devulapalli. I'm a recent alumni, graduated in May with a degree in biomedical engineering. Right now, in my time, I'm applying for medical school, of course, but I'm doing research with Dr. Tristan Driscoll near the FAMU-FSU College of Engineering, and as well as you saw on the flyer, I'm the founder and CEO of Athengaurd Technologies. So biomedical engineering, I like to put these pictures because these are some of my closest friends that I've been through with during my junior and senior year. When you start engineering, I'm not sure if there are any engineers in the room or anything like that, but yep, shout out, there you go. You kind of get a little isolated because you're on a different campus. So my first 2 years of college were mainly here. Once I met all these brilliant people, things just were taken to another level. We were always jumping off on each other in terms of ideas, going to different conferences and presenting. So in the middle picture, that's our whole lab group where we went to Baltimore. Definitely recommend going, by the way, if you can. And how this all started was, I was a space kid. When I was growing up, space shuttle launches were literally happening every month, okay? I wanted to be an aeronautical engineer for the longest. Every time it was summer, I always begged my parents, could we go to the Kennedy Space Center and things like that. And it's funny enough, I'm from Tallahassee. So in the middle picture here, this is really close to the integration statue over there. I think I was probably about a year and a half year old with my dad. And FSU has grown since then. Obviously, construction's still there, as you all know. I heard Sally Hall is going to be taken down. Are there any Sally folk here? Okay, one. Okay, it's not great, is it? No, yeah, that's been there since I've grown up. It's been there since my dad attended Florida State. So Tallahassee has been a really integrated part of my life. And as I went through high school, I started getting slowly more involved with FSU and engineering and what that's all about. On the far right, you can see President Thrasher. I met him when I was a junior in high school. Taught him how to land a space shuttle. Didn't really go well. I did plenty of space competitions. I started seeing the College of Engineering for the first time. On the far right, you can see one of the engineering labs focused on biomechanics and using robotics to mimic the behaviors of animals and bugs. So I think this one in particular, they were trying to mimic the grappling of a gecko across a tree to basically help mine workers who have to climb high elevations for mining minerals and things like that. I think that was the project. I'm not sure if it still continued, but that and all these experiences high school got me hooked. And then FSU kind of came along around my freshman year of high school. So I'm kind of high school was kind of a blur to me. It was kind of very fluid. Senior year, freshman year, just kind of all felt the same to me. Jim Moran, the School of Entrepreneurship, had a summer camp for high school students. So that was kind of my first introduction to the Innovation Hub. We had a tour here. We saw the VR headsets when they were first a big deal. We got new printers now, but the old ones before called Dremels were a little bit, older. But nonetheless, I was I want to be here. This is the place I want to be. And then Endgame happened, which all you know how big that movie was. And then COVID happened. And I started getting involved in medicine. I did a CNA, Certified Nursing Assistant program at my high school. I was shadowing in the hospital, doing rounds with my friends every day, working with COVID patients on ventilators and things like that. And seeing the trauma that their families and what they had to go through, I kind of realized that there's more to medicine that I could potentially help versus in aerospace. So I switched from wanting to be an aeronautical/mechanical engineer to a biomedical engineer. And then freshman year, I got into every possible organization I could, meeting as many friends as I could. I got involved with Dance Marathon, Leadership, the Center for Leadership and Service, doing a lot of community service, learning more about the community that I grew up in and things like that, and made a lot of friends along the way. I also got involved in research. I recommend everyone in here, I think since most of y'all are freshmen, I believe, IGEM stands for International Genetically Engineered Machine. It's an interdisciplinary research group / team where every year you use synthetic biology to solve a pressing challenge. Now, it doesn't have to be medicine. It could be agriculture. It could be diagnostics. It could be just even AI and computer software and like bioinformatics and things like that. And you get a free trip to Paris, so there's a win in everything. So that really kind of piqued my, that curiosity, that critical thinking aspect that is of what an engineer needs to be. I also got involved at the Innovation Hub for their design sprints. I did the one called Aging in Place, where we had to make like a smart home for elderly patients to have a better quality of life outside of just being in a nursing home. I joined a lab group, Dr. Driscoll's lab, around that time as well. And then circling back to aerospace and aeronautical engineering, I got to meet Neil deGrasse Tyson. I'm sure you all know he's a very famous astrophysicist. He came to FSU last January. So he, autographed a book for me and my sister. She got to ask a question, and for some reason he decided to present wearing socks on Ruby Diamond. I guess according to him, it was like very comfortable. And I got very involved with 3D printing. Using my community service, I worked with a lot of miracle kids that were going through a lot of various rare disease conditions and things like that. So I used the Hub's resources to 3D print toys for them. Really, they've been going through a lot in their life, and just showing them like something very meaningful that they haven't seen before was always like something I tried to accomplish through community service and things like that. And once that concluded, then I started like figuring out senior year what I want to like do, my whole passion, and like what I want to do. I obviously said medicine. I want to be a doctor, sure. I want to be an engineer, great. But going to India for fifth time, I kind of got to see, the city life, the cultural aspects that, growing up as a kid I didn't really see, just because, there were certain things on the roads and things like that my parents just, wouldn't let me walk around. So, it's true, cows stop traffic. They are, considered holy in Hinduism and things like that. So in the bottom left, cows stop traffic for roughly 20 minutes. So that's a thing. That's not like a rumor. That actually happens. Obviously, I said the city life, seeing various temples, just learning about my Hindu culture and things like that. And also learning about medicine there, learning about the healthcare system, learning about what struggles a lot of construction workers they can see in the middle. Those construction workers there, they work 15 hours a day, and they only get paid $2. And they don't have any protective equipment, no hard hats, nothing like that. They just have towels to just keep them cool, working in these very strenuous conditions. I worked with a cardiologist who some of these workers actually were his patients, learning, and realizing that congenital heart defects is a big problem. I was very familiar with it from Dance Marathon and working with those kids, and some of them are still waiting for a transplant, as that's the only solution. So I got to work. My honors thesis was focused on creating a new medical device for children that provides efficient blood supply to their heart. That was what my honors thesis about. And for construction workers, and I'll get to it later, more specifically football players, developing some an affordable padding that gives them protection while they're working out in the field in these very stressful conditions. To learn more about congenital heart defects, I went to Mayo Clinic. It's the best place you can go. It's right down the hall, right down in Jacksonville. And you can see on the far left, my right, your left, it's kind of like the evolution of ventricular assist devices. Essentially what they're for is to improve blood flow for the heart and improve the, say, ventricle that pumps oxygenated blood to all the organs in your body. What I found interesting about it is you can see how small each one was over time. The one on the far right, which was introduced in the 70s, is roughly like the circumference of my hand. And that was implanted into patients, and it worked great, but it was really heavy. It was like 15 pounds. So most people were wheelchair bound. And then now, for adults, it's called the HeartMate 3, which is very small, probably roughly the size of my palm, a little bit within my palm. But those are for all adults. They don't have it for kids, because the problem is that blood doesn't like friction. So when friction, so if you guys experience like a cut before, what happens? You guys, your blood starts to clot a little bit, and you kind of have like what they call a scab, right? So imagine that happening inside a pump, and those clots are forming very rapidly. That is the problem for kids, is that they can't have a pump like this because making it too small causes those blood cells to clot, the platelets specifically, to clot even more. So it's very high risk to ever do a surgery with a device like that without seeing really like good outcomes. So I supervised and watched a couple of heart transplants, working with Dr. Leone, and if you ever do go to Jacksonville, Mayo Clinic lets guests just eat hospital food. It's probably the best hospital food you ever get. Some high quality stuff. I was genuinely shocked like how good it was, because they had like, they had some really good chefs there. And I know this is just fish tacos with some pretty good steamed broccoli, but they make the best pizza. I know Papa John's is Papa John's, but it's not Mayo Clinic pizza. So after Mayo Clinic, more traveling, more community service, things like that. Continued my honors thesis and defended it successfully. I actually went to the Seminole tribe for a few days. They had an American Indian Indigenous art festival, and I learned how to gator wrestle. So that's apparently the world #1 gator wrestler. I guess that's a thing. It's an actual competition. So very dangerous. Don't do it, of course. I went to Baltimore, as I mentioned before, and presented my work on football research. So now I'll get to it. Football, as we know, is a very fun sport, enjoyable to watch. Woohoo, we beat Alabama, right? And we got Miami next Saturday, so that will be, I hope College Game Day comes to, by the way. When it's a top 10 matchup, they have to show up. They robbed us in week 1, so they have to come this Saturday. Oh, next Saturday, excuse me. So football is a dangerous sport. Concussions is the overarching term of the sport. And just to show kind of how most of these hits, this is like an Oklahoma drill. It's kind of banned now. This is an old video. But, youth, kids, and high school players, I'm sure maybe some of you played football. It's a very dangerous sport. And many parents are concerned for the kids playing the sport for a long duration of time. So I went to investigating. A lot of my friends played football. I've seen them get knocked out of a game, and unfortunately, they would miss like a very important playoff game, and that's where recruiters are there. And most people in most schools don't have athletic trainers to diagnose, hey, your player has a concussion. Most coaches like, he's our best player, he's got to go back on the field. So in most states, that's actually the case. So obviously these are very extreme cases where coaches know, yeah, he can't go back out there. But some people take some pretty big hits, and they'll try to walk it off after 15 seconds or so, and they shouldn't be back on the field, but they end up on the field. So helmets have always been like the whole overarching thing. Guardian cap is like, the new innovation now. But I wanted to look a little bit more and learn about the padding inside. So on the right here, I'll pass this around, is what is found in helmets. It's kind of like a vinyl kind of foam. It's very stiff and rigid, doesn't have a lot of give to it, which isn't great. Because if you had a lot of y'all drive cars, the car bumpers there, the reason why they look like the crashes are so crazy is because the bumpers are designed to deform. If the bumper was designed to be very rigid, you actually take more of that force during a car crash. So that's why during those car crash simulations that you might see on Instagram or TikTok and things like that, the reason for that deformation of how the crash looks is because they want it to do that. It wants to crumple and absorb that energy. It's simple. If you punch a wall, you're going to feel all that force because the wall won't move. But if you punch like a piece of styrofoam, the styrofoam will absorb some of it and obviously break, but it's a little bit softer and your fist won't hurt as much. So I'll pass it around just to give a perspective. Here you go, just to see. So for both youth, high school, professional, college, they all have that. And on your first to the right is the padding that I've been working on. So 3D printed padding to absorb most of that energy. We're able to get 60% reduction in that, which I'll also pass around. Version 1 and version 2. Pass these around, thank you. So the idea here is for it to deform and crumple and take up all that energy. And this took over the course of roughly like 2 years. So I had this idea freshman year of college, senior year of high school kind of thing, but I didn't know what to do. I had resources here at the Innovation Hub. I had my coursework at the College of Engineering, which helped a lot with that. But really the innovation aspect of understanding what is the problem here. Is it really the helmet or what's in the helmet? Because everyone can go around and just make a new helmet, but does that serve the purpose of what needs to be done? Every year helmet companies are making new helmets, right? But clearly we're still seeing concussions, so obviously that's still a problem. So I continue my testing. You can see like a fully padded version of version 1 right here on the right, and then what typical helmets look like on the left. And we put it through impact experiments like this. We called it like the kabong machine, because we had a lot of elementary kids come in and try hitting it as hard as they can. You know that punching bag thing where you try to get the highest score? We try to do that with them, just like see how far they can go and get high of a value. And that was like really, fun way of just explaining how concussions work and, understanding the magnitude of it. And from that testing, getting the data that we got, 60% reduction, great. 43% reduction in the rotation of your brain, great. All right, good. So now let me take my entrepreneurship skills that I learned from classes. Some of them I actually took here at the Hub. Specifically, it's called Biomedical Innovation and Entrepreneurship is what the class was called. But any STEM entrepreneurship class will do. I completed my minor in commercial entrepreneurship, so I recommend that too, since it's like purely online. You get a lot of flexibility. Miss Garner and I forgot, there's one more professor that teaches it. It'll come to me later, but both of them are very fantastic in explaining it. It's very interesting, very easy to understand. And you kind of understand like how like a Mark Cuban, those Shark Tank people, a Bill Gates, and Elon Musk for that matter, Jeff Bezos, all these people, how they took a simple idea, a problem, and made it a suitable business that lasts long. Because anybody can just walk around and have an idea, but a good idea should also have a good execution as well, right? Any solution for that matter. If you want to make a new type of shoes that are more comfortable for elderly people, you can just make the shoe, but if it's too expensive, no one's going to buy it. So how can you make it affordable and convincing investors that this is a great idea, right? The product is one thing, but the story is another. So I went out and about all spring of senior year. I did the Innovation Challenge, and then I flew to Notre Dame for the ACC and Venture Prize. I went to USF a little bit later for their pitch competition, and then I had my senior design competition as well. All great results for the most part, but like the one takeaway from all of these is that you only get 10 minutes to, or even like sometimes like ACC is like 2 minutes. You only get 2 minutes to share a story, right? I know I'm talking here for like probably 15, 20 minutes, but that's the challenging part for entrepreneurship. That's a challenging part for innovation because, as technology is getting better, it's almost like the attention span that we have gets smaller and smaller. So the moment you have an idea and you know what you want to do with it, find the person, whether it's Wes, whether it's Ren, whether it's Jackson, whether it's Ken or the director here, anyone, just say, give me like 2 minutes, tell me your idea real quick. What can I do to get there? And that's kind of how it started. My freshman year, I took IDS 1107, the Seminole 100 class with Wes, and I told Wes about this idea. And I saw the ACC and Venture Prize pitch. I saw the Shark Tank pitches and things like that. I was like, I want to eventually, hopefully be there. Now, I'm showing you this in 20 minutes, but this is over a course of 4 or 5, even if I consider high school, 8 years. But I know a lot of people in this room that, that might be a daunting task, but if you have a passion or you have something that you're interested in, it'll take you wherever it will take you, right? The effort that you put into it is the effort you'll receive back. If you're really, invested in what you want to do, and whether it's, making the world a better place or making it accessible or whatever the goal is, there's people around you that will support you, right? So after all these competitions and whatnot, now I'm working on really my true passion, which is cardiovascular medicine. I love football. Athengaurd's still continuing, working with TOC and the football team to hopefully do a clinical study next year. But my topic here is congenital heart defect. I've met a lot of patients. I've had a few family members that have congenital heart defects that's affected them the whole life. And this one in particular, I know there's a lot of words and things like that going on, but really this condition, hypoplastic left heart syndrome, is really the difference between this ventricle you see, number 5, and then this one here. At birth, most kids with this condition, their left ventricle doesn't develop that well. So all the oxygenated blood, that is processed cannot be shifted correctly, transferred to the organs that keep us alive. So that's a problem. And so from day one, surgery after surgery after surgery, they have to get this fixed, but that's not the final fix. The final fix is getting a heart transplant, but those are relatively rare and inaccessible for most people. So this is actually, I'll pass this around too. So this is a normal heart. I'll pass it around. This is just 3D printed. And then this is an example of a hypoplastic left heart. So you can kind of see why it's a little bit wider, because there's a lot of tissue development that occurred in the left ventricle, which makes it not feasible for a functional heart. So my honors thesis was focused on that. I did a lot of cell culturing, growing cells in the lab, doing biocompatibility testing to make sure the material that I utilize is safe for surgical implantation. So that's what a lot of this is going on right now. And now it's successfully funded by the FSU College of Medicine's Institute of Pediatric Rare Diseases. This is version 2, and this is kind of the mock-up of how this would be surgically implanted. I'm working with Mayo Clinic, obviously College of Medicine, and plenty of researchers in India as well to get this going, because one problem that many kids is facing is this. So right now, this is the current size of it. I'll pass this around too. Sorry, I got a lot of props. But hopefully we can get it to work so it fits, so it's as small as pretty much the size of half my thumb. So this small now. So I'll pass this around too. And I know I shared probably a lot of things right now. It's this kid's got a lot of projects. How does he sleep? I don't sleep. Okay, so Wes knows this, especially during my sophomore year. It was pretty brutal with my course load and things like that. So I recommend getting 8 hours of sleep and focus on that one passion that will translate after you graduate. You don't have to make a business. You don't even have to make a solution or an idea, even in your 4 years of college. But there's always going to be a need out there for something that you care about. And if you use the course material that you learned, whether it's at the Innovation Hub or at your respective college or campus, anything's possible, right? So I guess my takeaway is just always stay curious, always ask questions, and don't sit in the back of the class, because that hurts the first 2 things. So that concludes my presentation. I know I spoke a little bit. I know pizza just came, so definitely grab some pizza, and thank you for the time.